Good morning.
Good morning,
Good
ma'am.
morning, ma'am.
Am I audible perfectly? Good morning. Am I audible perfectly?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, okay. Thank you. Okay. So I'm going to share the screen. Is my screen visible?
Yes, ma'am.
Okay. So I think last class we have network issue. Okay. So today what we will do, we will discuss some important points of last class. So I think I have shown you this PPT also. Means I have explained in that class. So there is a thermometer and thermometric property. So thermometric property means it is the property of system which will define the temperature. Okay, it will give assign values to the temperature. So which will change as per the condition of the system, and that value will give the temperature. Okay, so there are the different types of thermometers. Here you can see it is first one is the constant volume gas thermometer. So here your thermometric property is your pressure. Pressure means in this case due to the change of your pressure, that temperature can be find out by using the ideal gas equation. Then we will have the constant pressure gas thermometer. Here also due to the change of the volume, we will have the temperature value by using the ideal gas equation. Then we will have the electrical resistance thermometer. So in this case, your thermometric properties is your resistance. So this is the change of wire resistance will give you the temperature readings. Then we will have thermocouple. Here we are using the thermometric property is thermal EMF, electromotive force. So with the change of that electromotive force, which will be taken by the voltmeter, that reading can be taken by the voltmeter. That will give you the temperature reading. Temperature reading means that EMF will have some relation with temperature. That equation I will show you. From that relation, we can find out what is the temperature. So in case of the thermocouple, we are using the two dissimilar materials. So I will show you that idea. Then last one is your mercury in glass thermometer. This one is the common example of your measurement of temperature. This instrument is used in our household application. Suppose to measure the temperature of your body, we are using that mercury in glass thermometer. Here you can see that this is the mercury in glass thermometer. Here the thermometric property will be length. Length means due to the change in uh, length of the liquid column. So that will give you the um, measurement of your temperature. So all of you know that there are the temperature scales. So there is a temperature scale means at Celsius scale and your Fahrenheit scale. So 2 point temperature are used in case of your mercury in glass thermometer. So one is your ice point, another one is the steam point. So ice point is that temperature will be 32 degrees Celsius. 32 no, in case of the Celsius case that will be 0 degrees Celsius. In case of the steam point means it is the temperature is 100 degrees Celsius. That is related to the boiling point of the temperature. Okay, so that is your Celsius scale, and then you will have the Fahrenheit scale. Okay, so there is also 2 point. One is 32 degree Fahrenheit, and another one is your another one is your how much that one is. So I think that value we will have is your 212 degree
200
Fahrenheit. 212 degree Fahrenheit. Okay, so that is related to your what I told, that is Fahrenheit scale. So there is also Kelvin scale. So Kelvin scale means it is thermodynamic temperature scale in SI unit. So mm, these are designated by the capital K, right? Capital K. So all of you have idea about this. When there is the lowest temperature on Kelvin scale, then that is that is your 0 degree Kelvin. Okay, so this is about your Kelvin scale. Then I will tell you the all the uh, instrument details. So next one is the constant volume gas thermometer. Here you can
Kelvin
see
scale is
that
not based on 2 points.
no, it is not reference to point. Sorry. So it is related to your absolute zero, that is your 0 Kelvin, 0 degree Kelvin. Okay. So next one is your constant volume gas thermometer. Okay, so here you can see that it is your YouTube flexible tube is used. This is the two limb. It is connected to the capillary tube, and this one is the B is your valve inside which we will have a certain gas, some amount of gas will be there. So one side of the limb is open to the atmosphere, and here it is the aim is we can say it is one limb of your manometer. So in case of the constant volume gas thermometer, what we are doing, so when this uh, uh, valve will taken to the system where you want to measure the temperature. Suppose it is your hot system and you have to measure the temperature of the system. So you have to bring this ball in contact to the system. So what will happen? So the gas which is present inside this ball, that will expand. So due to the expansion, there will be the pressure difference between these two limbs. So what will happen? There will be the difference in these two columns. This is the difference of height, which is taken as Z, taken as Z. Okay. So then we can write our pressure formula, that is atmospheric pressure plus rho mzg. So here we have taken that mercury manometer. So density of mercury will be given. That is, what is the value? Any one of you please tell me. What is the value of that mercury density? Density is your
13.6.
26, 13.6
13
kg per meter cube.
616 kg per meter cube, right? So in this case, height, how much we are taking? Z we are taking 760 mm of mercury, right? Am I right?
Yes,
Okay.
ma'am.
So when it is 1, Z is usually 1 meter, then this will be rho m will be 1.3366 bar. So later on, I will discuss to you this thing in case of your pressure chapter. Okay, so what will happen here in this case? We will measure that, we will calculate that pressure, then we will write that ideal gas equation. So this is the relation delta T is equal to V by R and delta P. So here you can see that temperature will change with respect to your pressure, and this variation is linear variation. So from here you can get what is the temperature. Okay. So like that, next thermometer is your constant pressure gas thermometer. So in case of the constant pressure gas thermometer, so in this case your volume we are considering as the constant. Okay, so next one is your constant pressure gas thermometer. In this case, what we are doing, we are considering the pressure as a constant. So pressure as a constant means we have to fix this jet difference of the height, and volume. We can say that volume of gas in this case we are varying. So that variation of volume will use in this ideal gas equation. So this equation is used to find out the temperature. So here in this case also temperature will vary linearly vary with the changing volume of the gases. Okay. Volume of the gas. So next one is your electrical resistance thermocouple. So all of you have about this one. Okay. So in this case we are using the metal wire. So in this case, your basic resistance wire which we are using is the platinum wire. So in this case, this platinum wire will that resistance will change due to the change in temperature. So in this case, temperature is the resistance changes the thermometric property. Okay, so all of you have idea about that weight stone bridge circuit. Okay, so it will work on that principle. So in this case, we are using this formula. That is R is equal to R0 multiplied with 1 plus AT plus BT square. So A and B are your constants. So this equal that change of resistance will follow the quadratic equation. Okay. So here R0 is the resistance of the platinum wire. Okay, resistance of the platinum wire. Okay, so this equation will give you the change in resistance, and that will here it is your temperature. So this relation can give you the what is the amount of means what is the amount of temperature of any system. Okay, so mainly this type of electrical resistance thermometer I use for the calibration purpose. So to calibrate the other thermometers, so these are used. Next one is your thermocouple. So thermocouple, as I have already told you, it is the best upon the change of the electromotive force. So here we are using the two dissimilar material A and B. So two dissimilar material means sometimes we are using that copper constituent or chromel, aluminum, or sometimes platinum, rhodium. So these combinations are mainly used. So here you can see that here it is ice water mixture, and both the material are connected to a point. So this will connect it to the test junction, means where we want to measure the temperature of any system. So that will be so here you can see that here it is the hot junction and cold junction. So the working principle of this thermocouple will based upon the Seebeck effect. So due to the change in temperature and feeling of hot and cold will give you that your change of EMF. So which can be um, taken by the that reading can be taken by the voltmeter. Okay, so here you can see that both are connected to the potentiometer. Here it is connection is copper wire. Okay, so in this case we will have this equation, thermocouple equation. This is the cubic equation. The format equation is cubic. So here you can see A is the EMF, and like in case of your resistance thermocouple, A, B, C, D. These four are your constant. Okay. So this T is your temperature. So by using this formula, we can find out what is the temperature. Okay, so last class we have discussed onto this. We have discussed the thermometers and thermometric property, and that different types of thermometers we have discussed. Okay, so which will give you the measurement of the temperature. So temperature is the intensive property of the system. Okay.
Ma'am, which effect is used here?
G.
Which effect is used here?
Seebeck effect.
Okay.
Ma'am, what is Seebeck effect?
Effect means when there is the when any material will come in contact with hot and cold junction, that will give you potential difference. So that one is the Seebeck effect. Okay.
Yes, ma'am.
Okay. So today we will continue from the pressure measurement. So it is also one property of the system. So pressure, all of you have no idea about this one. Pressure means it is the force per unit area. That means the so as per the continuum. Okay, so pressure it can be defined by the two independent properties. One is the force and another is the area. Okay, so force is it is the normal force which is exerted by the system against the unit area of any surface. Okay, of any surface, that is your force per unit area. So as for the continuum, as per the continuum consideration, this P can be defined as delta Fn divided by del A. So it is the smallest force with respect to the smallest area. So this is your pressure of any system. So there is one term, that is your stress. Can anyone tell me what is the stress? So here also the same thing we are telling. The unit is also same.
Stress works inside the material and pressure is external force.
So yes, pressure in this case in the internal resistance we are considering. Okay, so that is your stress. The unit of pressure is what? Unit of pressure is your Pascal. So Pascal sometimes the Pascal is not what it is Newton per meter square. Okay, so also we are representing in terms of the bar. So bar is equal to your 10 to the 5 Pascal, right? So it is also equal to the 100 kilopascal, and also it is equal to the 0.1 megapascal. Okay, so sometimes we are measuring this pressure, or we are defining this pressure in terms of the standard atmospheric pressure, then that we can write as 1 atm or atmospheric. So that is equal to 101,325 kilo Pascal. Okay, so there are the different terms of your pressure. I will draw that diagram. It is quite difficult to draw with the help of this digital pad actually. So please see this diagram. Here I have written the relationship between different types of pressure. So here you can see that there is one reference line. This is known as your perfect vacuum or reference point from where we can find out the different pressures of the system. So here you can see that it is the atmospheric pressure. As I have told you, atmospheric pressure means it is a standard pressure. Okay, so there we will have the gauge pressure, positive gauge pressure and negative gauge pressure. So these two gauge pressure have considered above the atmospheric pressure and below the atmospheric pressure. Okay, so from the reference pressure or perfect vacuum line, reference line, we are considering the absolute pressure. So one is your absolute pressure below atmospheric pressure, another one is the absolute pressure above uh, atmospheric pressure. So this are with this is also with reference to your um,
Ma'am, your voice is not
local.
coming clearly. It is like a bit hazy.
Hello.
Yes, ma'am. Your voice is not coming sharp. It is difficult to understand.
Okay. Is it audible perfectly?
Now it is clear. Like that time it was very hazy.
Uh-huh. Okay, okay. So these are all different pressures. Here you can see that it is the atmospheric pressure. So with reference to the atmospheric pressure, we have two gauge pressure. One is the positive gauge pressure, another one is the negative gauge pressure. Okay. So then we will have this absolute pressure. So this absolute pressure we have taken from that perfect vacuum line. So what is that absolute pressure? The absolute pressure is nothing but it is the actual pressure at a given position is defined as absolute pressure. Okay, so it will measure relative to your perfect vacuum or absolute vacuum or absolute zero pressure. Okay, so most of the pressure measuring devices are calibrated to read zero in case of your atmospheric condition. So that instrument will indicate the difference between the absolute pressure and local atmospheric pressure, and that difference is given as the gauge pressure. Okay, so what I mean to say that your instrument will measure the pressure measuring devices or instrument will measure the gauge pressure only. Okay. So that is your difference of your difference between the absolute pressure, this positive or negative, with your atmospheric pressure. So gauge pressure we can write that minus P atmospheric. Okay. So another one is the P absolute. Okay. So gauge pressure can be find out by these two relation. So one is your P at absolute minus P atmospheric pressure. So this relation is find out from this when your absolute pressure is above atmospheric pressure. In that case, you have to take this relation. When your absolute pressure is below the atmospheric pressure, you have to take this relation. So all the measuring devices that will measure only the gauge pressure. Okay, what my point? So these are your different terms. Okay. Okay, what do you mean by perfect vacuum? Perfect vacuum means in this case, your there will we can consider the consider that there will be no particle are present in that case, or there is the momentum is zero. So that is known as a perfect vacuum. So the pressure relative to your perfect vacuum is known as your absolute pressure, as I have already told you. So a relation. So from this relation also you can get the what is the absolute pressure. So absolute pressure is equal to your P gas plus P atmosphere. Okay. So this relation is used. Okay. So got my point. So now I will discuss the different devices used for the pressure measurement. Okay. So this is the one common device that is known as your bottom tube pressure gauge. Okay. So it is one mechanical device which will measure the pressure of any system, pressure of any fluid or any system. So in this case, here you can see that it is connected to the streamline or fluid which pressure we have to measure. So it is the form of your bent tube. It is a bent tube structure inside which we will have the hollow. So what will happen when it will come in contact with the fluid? So that pressure will be exerted inside the tube, and there will be the deflection due to the pressure. Okay, so it is connected. One end is connected to the pointer. You here you can see that it is your mechanical linkage. Okay, so gear pinion arrangement will be there. So due to the deflection, this pointer will move on the calibrated dial. So here we will get the pressure reading. All of you have seen in many labs, I think. If you have not seen, so I will show you during the conduct of your lab. So this one, if you are observing here, it is the pointer which will read the values uh, already given on the dial. Dial. So as per your deflection, that pointer will move and it will read the pressure of any system. Okay, so this one is your mechanical device which will measure the pressure. So by using this device, we can measure the high pressure of any fluid. Okay, so here you can see that here I have mentioned depending upon the geometry or material thickness which we are using in case of your C type, C-shaped or bent type of tube, the pressure measurement can be increased up to the 7,000 bar. Okay, so with the help of this mechanical bottom tube pressure gauge, you can measure up to your 7,000 by such a high pressure. So advantages of bottom tube gauges are these are inexpensive, simple design, so it will give you the good accuracy. Except at low pressure. So low for the low pressure, we can use your manometer. So I will discuss that one, YouTube manometer. Okay. So that is good for measurement of the low pressure or low difference of height. Okay. So this bottom tube pressure gauge can be used for the high pressure. Okay. So this type of device are also can be used with the electrical devices like your LVDT. LVDT means it is your linear variable differential transformers. So it will measure the displacement. So these are not that much. Means here it will measure the displacement. So I'm not going to the details about this. So these C-shaped bent bottom tubes can be reached up to 60 bar. And for the high pressure, as I've already told you, you can use the different materials. Here, geometry. Here I have mentioned that one helical and spiral type bottom tubes can be used to increase the pressure difference which can be measured uh, for any system. Okay, so yeah, this type of geometry you can use for the high pressure. So this is all about your bottom tube pressure gauge. Now coming to your YouTube manometer. Okay, so there we will have the different types of manometer. All of you are aware of this one. Okay, so I will draw that one. So this one is your closed. So these are different arrangement of your YouTube. Not here you can see that there is the difference of water column is given in terms of the chair. So this will indicate your gauge pressure. So gauge pressure, I think here I have written. So this is the difference of your P absolute minus P atmospheric. Another one is the P atmosphere minus P absolute. Okay. So depend upon your um, mm, absolute pressure, this gas pressure can be find out. So this type of YouTube will use to find the gauge pressure. Then this is also YouTube manometer. It will here it will indicate your vacuum pressure. Okay, here you can see that in this case this will be the vacuum pressure. Okay, so this is your closed YouTube. Above it is the evaporated type, so it will give you the absolute pressure. So mainly there are in the market there are different types of pressure measuring instruments are used. So one is your pressure transducer. Have you heard about this pressure transducer?
No, ma'am.
No, ma'am.
So nowadays it is widely used. So in this case, this one we can also tell it is one type of sensor. Okay. So in this case, like your temperature measuring instrument, there we were using some thermometric property, right? Here also in this case also in pressure transducer, and there will be the various techniques which can be used to convert the pressure effect to an electrical effect, such as your change in voltage, change in resistance, or change in capacitance. Okay, so here I am not fully writing. It is change of voltage, change of resistance, and change of capacitance will give you the pressure measurement. So here the change of all these parameters will give you the uh, pressure of any system. So we can say that these are all uh, properties or parameters which can give the um, which can be used in case of the pressure transducer. Okay, so these pressure transducers are it will measure accurately, and accuracy is very good in this case. Also sensitivity is also very high in this case. By using this pressure transducer, we can get a faster and precise result. Okay, so in this case, we can the range of pressure we can measure from the very less means in this case less than 1 atmosphere also we can measure, and above that 1 atmosphere can be also measured. So these pressure transducers are mainly calibrated to the zero, and then it will read the gauge pressure. As already I have told you that any instrument or equipment which are used for the pressure measurement, that will read only the gauge pressure. Okay, so there are other pressure measurements instruments
Ma'am,
also.
you said
Strain.
calibrated to zero.
Yes,
Then, like, how?
मीन्स जब आप एटमोसफियर में उसको रीड करेंगे वो हमेशा जीरो में रीड करेगा, उसका पॉइंटर जो जीरो में दिखाएगा.
Okay, ma'am.
अब समझ में आया. फिर
Yes,
आप
ma'am.
जब सिस्टम के पास उसको लाते हैं वो ऑटोमेटिकली आप एक रीडिंग दिखाएगा, है ना. तो वो है उसका प्रेशर, वो है प्रेशर एट द पॉइंट. सो दैट इज योर गेज प्रेशर. ओके, strain gauge pressure strain gauge, pressure transducer are also there. So here it will work. It will having a diaphragm type arrangement. So due to that deflection, we will get the pressure difference. So it will have your Wheatstone bridge arrangement जैसा है उसी टाइप का रहता है ठीक है. Then we will have the
हम तो इनका
yes,
वर्किंग मैकेनिज्म जानना इम्पोर्टेंट नहीं है.
हाँ, that's why. Electric transducers. Okay, so there is a piezoelectric transducer. So it will work upon your solid state pressure transducer. So it will work upon the principle of electrical potential, which is generated in a crystalline substance. So we can use any crystalline substance to get the pressure difference. So that will work on that principle. That is a piezoelectric transducer. Okay. So these are the different instruments which can be used to find out the pressure of any system or any fluid. Okay. So ये मार्केट में सब अवेलेबल है. तो जब आप बीटेक में प्रोजेक्ट करोगे तो तब आप देखिएगा एप्लीकेशन ओरिएंटेड कौन सा ट्रांसड्यूसर कौन सा devices you can use to measure the pressure. Okay, so these are the two basic properties which I have discussed to you. One is your temperature, another one is the pressure. So I have discussed to you the different instruments used to measure these properties. Okay. So next class we will continue from the pure substance. I think all of you have purchased your steam table so that we can solve some problem during our class. Have you all purchased? If you have not purchased, please try to purchase today itself so that you can understand it better way. So I have already told you, please purchase this data book, that is your KK Ramalingam steam tables. So you have to purchase SI unit based. Okay, ठीक है, purchase कर लो सब. So next class I will teach you pure substance and phase change. Okay.
मैम इसमें सबसे
Yes.
एक्यूरेट ट्रांसड्यूसर कौन सा है?
इसमें
यस मैम, सबसे ज्यादा एक्यूरेट.
जनरली मैं जो मेरे ये मैं यूज करती हूँ जो प्रोजेक्ट में वोल्टेज जो चेंज के हिसाब से आपका हो रहा है उस वो प्रेशर ट्रांसड्यूसर यूज कर रही हूँ.
मैम तो एक्यूरेसी प्रेशर रेंज के बीच में मतलब डिपेंड करेगा.
हाँ वो डिफरेंट, हाँ वो आपका डिफरेंट ट्रांसड्यूसर का डिफरेंट एक्यूरेसी रहता है और अनसर्टेनिटी भी रहती है. ठीक है.
तो मैम वर्किंग कंडीशंस पे डिपेंड करता है.
हाँ आपका वर्किंग कंडीशन के ऊपर डिपेंड करता है. देखिए प्रेशर ट्रांसड्यूसर जो है डिफरेंट रेंज का रहता है. आप कितना प्रेशर तक मेजर करोगे. जैसे कि मैं सिंपल पाइपलाइन में वाटर फ्लो का यूज कर रही हूँ और एक जगह में एक हाई प्रेशर फ्लूइड का यूज कर रही हूँ. तो आपको वो सोचना चाहिए होगा वो कितना रेंज तक प्रेशर होगा. तो आप उससे हायर रेंज का लेंगे तो उसी के हिसाब से आप मार्केट में सर्च करोगे कि कौन सा ज्यादा एक्यूरेसी होगा. वो एक्यूरेसी आप चेक करोगे उसी के हिसाब से यूज करो. ठीक है.
यस मैम.
Okay. Okay. Thank you all. So I'll take your attendance. All of you, please unmute your mic. Roll number 1,
Present, ma'am.
2, 2, 3,
Present, ma'am.
4, 5,
Present, ma'am.
6.
Hello,
Present, ma'am.
ma'am.
Oh,
Roll 4, ma'am.
okay, okay. Roll 6.
Present, ma'am.
7.
Present, ma'am. 7.
8.
Present, ma'am.
9.
Present, ma'am.
10.
Present, ma'am.
11.
Present, ma'am.
12.
Present, ma'am.
13. 13. 14.
Present, ma'am.
15.
Present, ma'am.
16.
Present, ma'am.
17.
Present, ma'am.
18.
Present, ma'am.
19.
Present, ma'am.
20. 20. 21. 21. 22. 22. 23. 24.
23 present, ma'am.
Present, ma'am.
23 present.
Okay, 24.
Okay, 24.
Present, ma'am.
25.
Present, ma'am.
26.
Present, ma'am.
27. 27. 28. 29. 29. 27 present.
Ma'am,
26.
26. Present,
Yes,
ma'am.
ma'am. 27 present.
26 also present, ma'am.
Okay. 27 present. 28.
Present, ma'am.
29. 29. 29. 30.
Present, ma'am.
31. 31.
31 present, ma'am.
32.
Present, ma'am.
33.
Present, ma'am.
34.
Present, ma'am.
35. 35. 36.
Present, ma'am.
37.
Present, ma'am.
Ma'am, 35
38.
also present है मैम.
Present, ma'am.
Ma'am, 35
मैम
present.
35 प्रेजेंट है, उसका नेटवर्क इशू था.
अच्छा, चैट बॉक्स में लिखा है क्या? 38.
Present, ma'am.
39.
Present, ma'am.
39. 41. Sorry, 40.
Present, ma'am.
41. 41. 42.
Present, ma'am.
43.
Present, ma'am.
44.
Present, ma'am.
45.
Present, ma'am.
48. 48. 49.
Present, ma'am.
50.
Present, ma'am.
51. 51. 53. 53. 53. 54.
Present, ma'am.
55.
मैम
55.
45%.
56. जो छूट गए हैं बाद में दे दीजिएगा. 56.
Present, ma'am.
57.
Present, ma'am.
58. 58. 59.
Present, ma'am.
60.
Present, ma'am.
61.
Present, ma'am.
62.
Present, ma'am.
63.
Present, ma'am.
64.
Present, ma'am.
65. 65. 66. 67.
Present,
67.
ma'am. Present, ma'am.
68.
Present, ma'am.
69.
69 present, ma'am.
70,
Present, ma'am.
71,
Present, ma'am.
72,
Present, ma'am.
73,
Yes, ma'am.
74, 74, 74, 75,
Present, ma'am.
76,
76 present, ma'am.
77,
Present, ma'am.
78, 78, 79, 79,
29 लिखा है प्रेजेंट है।
present है तो 80,
Present, ma'am.
81, okay, 82,
82 present, ma'am.
84,
Present, ma'am.
85,
Present, ma'am.
86,
Present, ma'am.
87,
Yes, ma'am.
88, 88, 89,
Yes, ma'am.
90,
Yes, ma'am.
Ma'am, roll
91,
78.
ओके ठीक है
98
बाद में
present, ma'am.
बोलेंगे 92,
Present, ma'am.
93,
Present, ma'am.
94,
Present, ma'am.
95, 96, sorry 97,
Present, ma'am.
98,
Yes, ma'am.
99,
Present, ma'am.
100,
Ma'am.
101,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7,
Present,
Ma'am,
ma'am.
relative to
107.
was present, ma'am. It was a mic
8,
problem.
okay,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Yes, ma'am.
12,
112
1,
present, ma'am.
3,
Present, ma'am.
14,
114 present, ma'am.
15,
Present, ma'am.
16,
Present,
then
ma'am.
17, 17, okay, please tell me who are left.
Ma'am,
Ma'am, 48.
78.
78.
Yeah, ma'am.
Why you people are left? Over, I think. Anyone left?
Ma'am,
Ma'am,
roll
roll
29.
53, ma'am. 53.
Ma'am,
Ma'am, roll number
25. Ma'am,
अभी
25.
आप लोग कहाँ थे? आपका तो प्रेजेंट है। और
मैम
बताइए और कौन?
मैम
Ma'am, roll
11
29.
29
मैम 11 तारीख को तो मैं प्रेजेंट था मैम।
प्रेजेंट थे।
यस मैम 11 तारीख को तो मैं प्रेजेंट